Hello everyone, welcome back to MindSpread. Today we're going to discuss operations on sets. Now why is that important? It's important because most things in our existence interacts with one another. Take the example of the different coloured liquids in those glasses. If I mix one liquid into the other, the colour will change. And that's because an interaction occurred for that colour to change. A similar principle in maths. Different sets can interact with one another to make new sets with new properties. Okay, so let's get into it. Okay, so one of the first interactions we're going to look at is the union between sets. Let's make an example. Let's say we have the set A and also the set B. And let's say I want to create a brand new set which had all the elements of A and B inside. That would be the union of A and B, or AUB, as shown in the example on the right. If you ever forget the symbol for union, think about unification, coalescing everything in one. And that's what the union is. It's mixing all of the elements for both sets and making it into one brand new set. While we're on the topic of unification and unions, let's quickly discuss Somalia. Somalia is currently under a drought and lots of people and children are dying of thirst in that drought. We couldn't imagine our own family members or siblings dying of thirst. Water is one of the most fundamental needs for all living organisms. As the human race we are, let's unify together and help those that are less fortunate than us and those that need our help. In this video, I've linked a charity group which will appear soon. Donate anything to a charity, whether it's as much as you can or as little as you can. Anything makes a difference, and it's going to go to a good cause to helping people. A lot of people complain about the situations that happen in life, but I believe it's the actions we do in those situations that actually count. So let's do the best we can to help as many as we can. Okay, let's try an example. Let A be the set containing letters A, B, C, E, F, and B be the set containing letters B, D, R, S. Find the union between A and B. Okay, so the union between A and B would be all the elements of A and all the elements of B. The answer is given in orange below. You might have noticed that elements B are repeated twice in the set A and the set B. In the set capital A and capital B, you might see the lowercase element B inside both sets, yet our answer only mentions B once. And the reason is that repeated elements in a set are treated as single elements. Why? Because a set is a well-defined collection of objects and it doesn't matter or care about whether something's repeated or not, it's still well-defined. In this case, the lowercase b is always going to be lowercase b no matter how many times you mention it. Okay, we've covered unions. Now let's look at a different interaction known as the intersect. Again, let's have the set A and the set B, and let's combine the two. Now the intersect is basically all the elements that A and B share commonly. So all the common elements between A and B, the elements that they share. The intersect is given a symbol that looks like an N. The way I like to remember it is as intersect, N, intersect. They sound similar, so the symbol is an N, intersect. Okay, let's try an example. Let's have the set capital A, B, and C and the respected elements inside the brackets. Find A intersect B, A intersect C, and B intersect C. A intersect B. The answer would be all the elements that A and B have commonly, the elements that they both share. In this case, A and B share the elements lowercase b, lowercase e, lowercase f. And that's the only elements that are common between capital A and capital B. A intersects C, the next question. The only elements that A and C share are the lowercase letter a. No other elements are commonly shared between the two sets. For the last question, B intersects C, B and C actually have no elements in common, but they do have one element in common, and that's the set that contains no elements, phi, or the symbol given empty brackets. And that's because the empty brackets are not missing from either set, so they belong to both sets. Okay, now we know how to define the intersecting union between two sets. What if we had more than two sets? For example, three sets. So instead of A and B, we might have A, B, C. How would we define the union of more than two sets? Alright, let's say we had the set A1, A2, A3, A4, all the way up to AN. And we want to know the union of all of those sets combined. The way we would write that is that A capital U represents we're looking for the union, and beside it, we write all the sets. And we represent all the sets as A sub k. So capital A with a little k beneath it. And the k represents all the sets that can exist. Then we have to define the limits. What do we mean by that? So which sets are we actually looking at? In this case, we're looking at all the sets between A1 to AN. So at the bottom, I'd write down k is equal to 1. And on the top, I write all the way up to n. And this would be the union of A1, A2, A3, as shown in the brackets below, all the way to AN. The same is true for the intersect, but instead we do the exact same thing, but the capital U is turned into a capital N instead. And that would be the intersect of A1, A2, A3, all the way to AN. Let's try an example of an intersect of more than two sets. Capital A, B, C represents sets, with all the elements in brackets. Find the intersect of A, B, and C. Well, the answer would be the elements that all of them share. A, B, and C all have the element 1 inside, and A, B, C also have the element 3 inside. No other elements are shared between any of the sets. So the answer to the question would be brackets 1 and 3. Okay, we're on the final part of our video. If you made this far, well done. That requires a lot of determination and discipline. And trust me, that will pay off. The final part's going to be on complements and symmetric difference. Let's discuss complements first. If I have a set A and B, then A complement B would be all the elements of A that are not in B. And if I had the same set and I wanted to know the B complement A, basically the opposite way around, then it would be all the elements in B but are not in A. The way I like to think about it is anything with a negative symbol to the left of it means not this. So A minus B means everything that's not B. Or B minus A means that everything that's not A. Let's try an example to see this better. Let's try an example. Capital A and capital B represents sets, which are defined above. Let's find out what A minus B is. Well, that's just going to be all the elements of A which don't belong to B. The only element of A that doesn't belong to B is lowercase a itself. Every other element, so lowercase b and c, are also in the set capital B. Now for the bottom example. Well, that's all the elements of B that are not in A. So all elements that A doesn't have. And that would be lowercase d and lowercase e, because lowercase d and e are not in the set capital A. These are known as the complements. So the first one will be known as complement of B with respect to A, and the bottom one is known as the complement of A with respect to B. Okay, last thing to cover. Symmetric difference. Capital A represents a set, capital B represents a set, and the plus sign with the circle around it means symmetric difference. And it's defined as A complement B unioned with B minus A. Let's try an example. The definition of symmetric difference is given in yellow above. Okay, let capital A be the set containing A, B, C, D, and capital B being the set containing A, C, E, F, G. What's the symmetric difference of capital A and capital B? Let's work it out in parts. A complement B. Well, that would be all the elements of A that B don't have. The elements of A that B doesn't have would be B, D, and that's it. Now that's union with B minus A. And union means unify, so all of them together. So what's B minus A? That's all the elements of B that A doesn't have. And all the elements that A don't have is E, F, and G. Those are the only elements A doesn't have. So now we unified all of those together, or the union of them. You have B, D, E, F, G. And that's what the symmetric difference is. Okay, that's everything. Congratulations, you've learned all operations on sets. Thanks for watching. Don't forget to subscribe. Your support means the world to me.